Thanks for coming. We'll go over the topic, which is why OpenStack, we changed the topic a little bit. Why OpenStack runs best on vCloud Suite. And the answer is essentially VMware integrated OpenStack beta. We had to keep that placeholder topic for the session so that we could announce it at VMWorld. But I will touch upon all the aspects of how OpenStack runs best on vCloud Suite and how it can leverage all the components of vCloud Suite. Briefly about me, I am Arvind Soni. I work as a Senior Product Manager here at VMware. I work on our OpenStack integrations with VMware, and now I officially work on the product called VMware Integrated OpenStack. With me is Lawrence. Lawrence is from TradeStation. I'm going to give my perspective on OpenStack and how our product brings OpenStack to your data center. Lawrence is going to bring a customer or a user perspective into how they are planning to use OpenStack, what does OpenStack bring to their private cloud, and what kind of decisions they had to make with respect to OpenStack. Sounds like a good content plan. We were expecting a full house, but if you want to squeeze in, that's fine too. Feel free to move around. Legal disclaimer, all the announcements and products and features in this are in beta. So for what it's worth, all the legal statements over here apply. Essentially, the features and timelines are subject to change. That's the core of this. This is roughly the agenda. I'm going to recap what we have announced with respect to OpenStack here at VMworld. We'll go through and ask the very important question, is OpenStack interesting for your private cloud? And what kind of use cases does OpenStack bring or enable in your private cloud? We will also talk about how OpenStack and VMware work together. Then I'm going to hand it over to Lawrence to cover the TradeStation aspect and how OpenStack fits for TradeStation, what kind of value it brings to TradeStation. Then we'll talk more about the product, VMware Integrated OpenStack. Towards the end, we will build an OpenStack cloud. We will build a production-grade OpenStack cloud. That will be my demo section towards the end. And then we'll open it up for Q&A, right? Sounds like an exciting agenda, so let's get started, right? So our broader approach around OpenStack and in general open source products is that if you look at the kind of workloads that are being delivered on top of SDDC platforms, there is your legacy traditional IT applications, the Exchange, the SAP, the Oracles, the vertical integrated applications on one side, right? Those applications require reliability, security, zero downtime, right? You use all the excellent features of our SDDC platform. Then there, on the other hand, is a new generation of applications. These applications are more horizontal scale-out applications. The need for these applications is more around flexibility and agility to interact much more closely with the infrastructure, right? What I mean by that is you can create an application VM. Let's say it's running out of disk. You want to add a 50 gig, 100 gig extra disk to it. You should be able to do it by an API call. If you want to break down and isolate your networks across various application components, you should be able to create virtual networks on the fly, create load balancers on the fly, and things like that, right? Should be able to put them in an auto-scaling group if the demand increases and decreases over time. So these applications have different needs when it comes to how they interact with infrastructure, right? Another corner aspect of those applications is around portability, and there is a lot of momentum in the market around Docker. We made announcements around Docker as well, and it's centered around these applications should be able to move between different clouds, whether it's between this private cloud to that private cloud. And the use case, the business use case is, let's say you have a SaaS application that you're serving with the North American market. You want to take that to Latin America or Europe. You should be able to take that application and move it across geographies and meet your business needs. So that's one use case where portability directly impacts your business and gives them a competitive edge, right? So these modern applications, they heavily leverage a lot of open source components. And VMware has been contributing across multiple open source projects, including Spring, Hadoop for big data, Cloud Foundry for PaaS. And today we're going to focus on OpenStack, which is a framework so that you can build your developer-friendly cloud on top of SDDC products. So what's, in a nutshell, our summary, our strategy around OpenStack has 3 pillars, right? We want to contribute, we want to do meaningful contributions to OpenStack community, and it's not just integrating our products, but also doing code reviews, making sure the general OpenStack quality is improved over time, and also spinning up new projects and influencing the decisions in the community. So we want to contribute very meaningfully to the OpenStack community, right? We want to differentiate. We have invested years and years of research into building these SDDC products, the network virtualization, the compute virtualization, and storage virtualization. We want to bring in all those rich features to the OpenStack cloud as well. There is no reason why OpenStack should run on a compromised, crippled infrastructure. We want to enable the customers. The above 2 are not going to make much of a difference if you as a customer can't use OpenStack in your data center. So we want to make it simple for you to deploy OpenStack and operate OpenStack in your cloud. So those are the 3 pillars. I'm going to focus more on the differentiate and enable, and I'm going to briefly touch upon our contributions so far, right? The history of VMware and OpenStack goes before we even became the gold member of OpenStack Foundation. Nicira was the founder for Open vSwitch, and once OpenStack project was, the community came together, Nicira folks were the leading influencers and sort of they defined the Neutron networking project. And after that, once we acquired Nicira, we joined OpenStack Foundation as a gold member. We immediately, of course, released the NSX plugin for Neutron. And NSX is one of the leading software virtualization, network virtualization products used in the OpenStack deployments today. Since then, we have never looked back, right? In 2013, we added compute support. We added support for Nova to use vSphere. We added support for Cinder to use vSphere data stores, for Cinder to use virtual SAN, right? At the same time, we started working on ecosystem partners. If you are going to build a data center, you're going to need help from multiple vendors. I would be lying if I said there is a push button where you can go and spin out a cloud that will be functional. A lot of technologies have to come together, the storage, the network, the operations. So we value ecosystem very heavily, and in 2013, we started doing agreements with Canonical, Mirantis, so that we can deliver OpenStack to customers, right? 2014, we expanded our coverage to Glance and Ceilometer. Glance can use vSphere data stores to store images. Ceilometer is able to collect reports and metrics from vSphere environments. It's not just about existing projects. We have also started influencing and creating, incubating new projects. Congress is a policy framework. It creates policies for your cloud applications. So one good example is mostly in a lot of European countries, there are hard laws around where the application can run. So if an application can only run in certain country and within that compute load, you can define that policy and have a peace of mind that the application or VMs are not going to go out of that geography. So these policy frameworks, again, add a very successful level of automation and compliance requirements around any OpenStack deployment, right? And we continue to expand our ecosystem around OpenStack. We recently announced HP partnership. We have had SUSE and Red Hat partnership for quite a long time. So in a nutshell, if you see that we are expanding our contributions across OpenStack. We are influencing upstream contributions. We are creating new projects there. We are building an ecosystem so that customers have choice of consuming OpenStack from the vendors that they want. And this is not just my fancy slides over here. They're going this way and this way, but there are stats behind it. We have committed a lot of resources. We have committed about 20, now it's about 30 developers that we have full-time working on OpenStack code. And as I said, they not just work on their code and our integrations, but they review other people's code. They make sure the quality is up to par. We have a huge CI framework to monitor each and every change that's going into Nova, Neutron, and we run all those CIs on all the patch, right? Because quality is important so that you are enabled to deliver OpenStack in your data center. So with that, I'm going to focus on the second aspect, how our products bring differentiated value in your OpenStack cloud. So first of all, before that, let's talk a little bit about is OpenStack interesting for your private cloud, right? So if you look at the modern way of doing application development, it's around mostly centered around DevOps kind of paradigm, right? These are usually horizontally scale out applications. There is a lot of change, fast moving pieces. If you take Gmail as an example, you can see how many features they keep changing and adding behind the scenes. And you can imagine that there is a lot of framework that enables that kind of seamless, fast, agile rollout of features and applications. So this DevOps paradigm requires API-centric access to your infrastructure. It requires the application management tools to be able to interact closely with the infrastructure and leverage the flexibility of the infrastructure. OpenStack delivers that flexibility. Right? OpenStack delivers these APIs so that you can consume the infrastructure and build this next generation of applications. You can do things like provision a VM, add a disk, provision many VMs, create virtual networks, create a 3-tier application, create separation between them, isolation between them, and things like that, right? So this is really the core of these modern applications. So that's where we see most of the usage of OpenStack. If you look at all the user stories that are out there in the OpenStack Foundations page, a lot of them are centered around SaaS workloads, web scale applications, and then there is a significant chunk behind that which is around dev and CI and automated large scale testing environments that people are building on top of OpenStack. So those are usually the use cases that we are seeing commonly present in the market, right? So back to the question, is OpenStack interesting for your cloud? What's the answer? Well, it depends. Just like most of the answers in business, it depends. It depends whether you need these APIs, whether you have these large development groups, whether you are planning to make SaaS, mobile, web applications. And if you are, then OpenStack can add value to your private cloud. It can deliver these nice, flexible, developer-friendly APIs to your environment. So with that as the backdrop, let's try to fill in the private cloud. This is a very simplified view of a private cloud, by the way. I mean, I'm in no way trying to downplay the complications involved in building a large-scale data center, but this is more of an architecture kind of a diagram. So let's build a private cloud, right? You will start with the hardware or your virtualization technologies. That's a given. OpenStack or any other stack, it can't run on thin air, right? It needs the compute, the network, the storage. That's fundamental. You slide in the OpenStack components on top of it. Now, again, slide in is a little bit downplaying the complication, but you add the OpenStack components over there. It gives you all the APIs. It gives you the infrastructure services. So what is OpenStack doing? Making the infrastructure more consumable, easily consumable. You still need the operational tools, right? All these things are gonna, there will be some breaks. Some things you will need to troubleshoot. Your VMs are not getting IPs, those kind of issues. So you need operational tools. OpenStack does not come with a canned set of operational tools. So you need operational tools, monitoring, log analysis, troubleshooting, and things like that. And you need application management tools, things like, okay, I created an Apache VM, now I want to do some configurations on it, so you'd probably use Puppet, Chef, some other middleware kind of components. All those are still needed, right? OpenStack is just delivering you this API so that you can call into the infrastructure and get the infrastructure for your applications. So OpenStack delivers the APIs, it delivers the infra services, but you still need the software and the hardware for the infrastructure. You still need the operational tools, and very likely you would use some upper level application management tools. So with that in mind, we have been building private cloud for quite some time with our vCloud suite products, right? VMware has invested a ton of research into how to build private cloud, how to enable software-defined data center, as we call it. And all of these technologies that we have built fit very nicely in an OpenStack cloud as well. You start with our vSphere hypervisor, you connect it with OpenStack compute services. Then you can plug in NSX with the networking services. You can plug in vSAN or vSphere data stores to the Cinder / Glance services of OpenStack. You can use our VCOps, Log Insight, and even vCenter. vCenter is a great operational tool as well. Many of you guys are very familiar with vCenter. You can use vCenter to do a lot of OpenStack-related management. Cloud management aspects, ITBM brings you the financial insight. Hey, you just added a ton of storage. Who's using those storage? That's a good question to ask, right? You have to justify to your boss that you need to buy more storage. VCAC, again, adds a lot of orchestration, application lifecycle management, a lot of upper layer application automation benefits. So The key point here is that all of the vCloud suite components, which help you build a vertically integrated cloud in if you just use vCloud suite, they are all synergistic with when you add OpenStack into the mix. OpenStack just makes the infrastructure more consumable, more developer friendly, and it addresses that DevOps kind of use case, right? So in this model, your developers become very happy. They have the smiley face. But at the same time, you are able to operate that cloud. That's very important, right? You are able to use the familiar and reliable tools that you are comfortable with, such as vSphere, vCops, vCenter. You can use those to run the cloud. And that is the sort of our biggest differentiation. Your expertise and our experience in building the data center products, that's where our differentiation lies, right? So what we have done so far is make OpenStack fully functional. I'm going to focus a little bit on the foundational aspect of it because that's very important. You don't want to build a cloud on a shaky foundation. It has to be really reliable. Your compute, your storage, your network has to be solid, proven. You should be able to troubleshoot and diagnose them, right? So OpenStack is fully functional at this point on vSphere and NSX. We contributed Nova vCenter driver. So the way it works is, I'm going to give a little bit technical example, is when you say create a VM, it goes to Nova. Nova decides which cluster should I place this VM on. And once it has made its decision based on its scheduling logic, we hand it over to vCenter. Then vCenter uses DRS, which has a lot of research gone into it to avoid things like noisy neighbor, optimal placement, to actually put the VM on a particular host, right? So this is an example of how we are building, bringing the rich features of vSphere and marrying it meaningfully with the OpenStack world. You get the benefit of high VM density, you use less number of hosts and compute resources, and you are able to still use OpenStack APIs. So it brings in the cost efficiency in utilization of your compute resources. That's how the vCenter driver works. Neutron, again, NSX provides the complete L2 to L7 networking services. You can use Neutron fully with NSX. This is the NSX multi-hypervisor version for you guys who are familiar with NSX and different versions that we have. And it's fully functional with Neutron. This is actually probably one of the leading software-defined networking solutions that is used in OpenStack deployments. Same thing with Cinder. Cinder uses the VMDK driver. So when your developer says, hey, my application is running out of disk space, I want 100 gig volume to attach to my VM, they can just simply call the Cinder volume. When the disk is created, we back it up by VMDK, we put it in the data store. And when there is a need to do a storage vMotion, we do that seamlessly behind the scenes. For example, if he moves the VM to another place, we'll move the associated disk with that VM, right? So a lot of operational benefits behind the scenes come from our products, and this is all built on the experience that we have from the past in running large data centers. So all these drivers are open source, by the way, and you can download it yourself, go do the git pull on all of these and start building your cloud. I would highly not recommend doing OpenStack Cloud DIY, right? Or you can go to any of the distros. Any of the distros, they can all, as I mentioned earlier, they have agreements with us. They can build OpenStack Cloud for you on VMware products. But I would highly recommend that you go with our distribution. There are reasons that I'm going to cover towards the end. But what I wanted to stress here is, essentially, there is a lot of choice for you to build your enterprise-grade OpenStack foundation, right? You can use vSphere, you can use NSX, you can use vSAN. If you use vSphere, you get all the benefits of, as I mentioned, DRS. A lot of times people say, hey, I don't need HA and vMotion. Well, you don't need it for that particular VM. It's a kettle VM. But how about when you put the host in a maintenance mode? You would want to upgrade your host or replace it sometime in the future. When you do that, we automatically move it to the next host in the cluster. That's a good benefit. Otherwise, you would write some script, do the same thing some other way. vMotion does that for you already. You can move it across the clusters. There is long distance vMotion to do that, right? So there is a lot of benefit that comes with the experience and delivering features that have been used in a large scale data center. NSX provides the complete L2 to L7, as I mentioned earlier. They're pushing the frontiers in the network virtualization. Recently, there have been a lot of sessions around micro-segmentation, really small segments that you can put a small set of VMs and still have isolation. It's been very difficult in the past to do it. We can automate and we can do this very easily using NSX. NSX is also building a very large ecosystem with the networking gear vendors. So you will have proven technologies. So the software of NSX will run on proven and tested technologies of hardware underneath. And that's a big thing. If something breaks, we stand behind it, right? That's a big thing for your data center to have that peace of mind. Same thing with Cinder. This one is tricky. What people often overlook is you can slap in a hypervisor, do an iSCSI mount with a storage, but who has tested that particular compatibility? We spent years and years of compatibility list, building that certified list of storage, SAN, and NAS products, and that's very valuable. There is a reason why we did that, right? We have a large ecosystem of storage vendors that allows you to use various SAN and NAS, and if you use the VMDK driver, in all likelihood, your existing storage solution can be used in OpenStack deployment. You can use vSAN. Again, an example of how our innovations are going to influence heavily in OpenStack. You get a perfect balance of cost and performance by leveraging the local disk and SSDs on your host. So in a nutshell, our idea is essentially to give you the developer-friendly APIs and give you the ability to run it on best of the breed, proven technologies of VMware, right? That's pretty simple. In the next half, I'm going to talk about why our distribution makes a difference, where do we differentiate with respect to enabling the customers with our differentiation. Meanwhile, I'm going to take a water break, and I'm going to hand it over to Lawrence, who will cover the TradeStation and user story side of it. Lawrence?
Sure. Hey guys, I'm Lawrence Vandia. I'm the cloud engineer and scripting automation expert at TradeStation. Jack of all trades, cloud ninja, right? My contact info, like if you guys want to grab the slides or reach out, the slides will be up next week on my website, lawrencevandia.com. Just a little bit about TradeStation. TradeStation, we make a trading platform, and you can trade multiple asset classes. You can also run a ton of strategies on the platform as well. So I'd like to talk to you guys about our story to private cloud and our story to VIO. But that story starts with looking at our public cloud usage. Show of hands, how many of you guys leverage the public cloud? Yeah. So like the public cloud is extremely valuable, right? There's very little friction to build VMs. There's a phrase, 16 digits to freedom, which is your credit card number. And you pop that in and you can have VMs in minutes, right? You can quickly scale up. So like as your business needs, you can scale across as well. And it's also OpEx versus CapEx. So like instead of a huge cost in the front, it's just a smaller monthly cost. Now, while the public cloud is extremely valuable, we noticed that our public cloud usage was increasing with our developers. And that in turn makes the cost go up. So we decided to do a cost-based analysis to see what it would look like to host an internal IaaS cloud. And some things that we were trying to meet was to come up with a private cloud that could deliver similar value. And we also knew that because we were hosting it internally, that would in turn boost up our security because the data never leaves the data center. And then keep it this first use case, we would keep it geared to our developers as well. So some things I took into consideration, and like I'm not a finance guy, but my company is financial, right? So they wanted me to be very detailed. So look at power and cooling per rack U, look at like the SAN infrastructure needed, so like everything from like cabling down to the SFPs that go into the fabric, storage per terabyte, and of course, VMware licensing and support per core. And what we found was we could deliver a very cost-effective private cloud that we could use not to replace our public cloud, but to hedge that cost. Sort of another option to our developers. So we evaluated the top private cloud options. So we looked at Gartner, top right, picked all 3 or 4 of them, did our proof of concepts, and some of the requirements were from the business and from our developers were it would have to meet our workload. So our workload is, for the most part, 3-tier, web app and database. It also had to have an API. with the API, we also wanted to have a self-service portal. And then the kicker for us was that it be CloudFormation compatible. We have a group of savvy developers that, while they love building software, lately they really love to build scripts to build out their environment. So we had a huge investment in CloudFormation that we could not lose. So with that being said, we had to look at OpenStack because that was the only provider that could offer us that CloudFormation compatibility. So that was our #1 pro. However, we found a number of cons. One of the first cons being, by default, KVM is used with OpenStack as a choice of hypervisor. And you guys know that KVM is not HA, so there's no DRS, no fault tolerance, no HA. And then for us, we could not have no perceived downtime from the users. By default, there is flat networking. So like you guys know, real-world apps do not reside on a flat network. They reside on multiple network segments. And then no enterprise support. How many of you guys have tried to install OpenStack? Right? Challenging, right? Yeah, trying to parse logs and like figure out why this connector is not working with that connector. It's pretty challenging. And unless you have a significant headcount to support the ops and like the engineering side of OpenStack, it can just be like a daunting task. So we came up with a solution by looking at the community drivers for vSphere. Like that's how it all started, right? Like that's how our journey to VIO started. We found that there is a Nova Compute driver for vSphere, and then we started talking with VMware, and they let us in on this VIO. So we were like an early beta customer, and what we found was that they were offering a solution, VIO with vSphere, and then the NSX piece. So what we came up with was this platform that was fully enterprise ready. With vSphere, you get the HA, the DRS, the fault tolerance. Like if you guys are leveraging backups with some other third party, you could do that already. You want to leverage the skill that you have internally with your cloud administrators using vSphere, right? So we also got rich networking. So the ability to create that multiple network segments and have developers spin up VMs that could be isolated, VMs that have a layer 3 virtual router, and sort of have this rich networking with NSX. And then the best part, for us at least, was it was fully supported, right? So from the top to the bottom, full stack support. If you have a problem, with Nova talking to vSphere, or if you have a problem with Neutron talking to NSX, or let's say you click in Horizon and like it says it's building an instance, but then nothing happens, full stack support, one phone number to call. And for us being sort of constrained on headcount, that was a huge benefit. Yeah, so I'm gonna try to wrap this up pretty quickly. Like I know it's lunchtime and like the guy sitting by the door like slowly creeping out, right? So high level architecture. We have multiple VLANs here, and that's for our transport zone. You need a management one for OpenStack, and then based on your traffic coming in, that's all varied, right? So like we have one for like an internal, so secure resources from the data center, and then we have a load balancer VLAN for VMs in our cloud that is looking to be load balanced by, like whatever you guys have, ACE or like an F5, and then public facing. So that was a quick challenge. Just like the public cloud, we needed to make not all VMs, but some of our VMs public facing. So instead of having Neutron give out public IP addresses, what we did was we created a VLAN that had the same number of hosts that we carved out from our public address block. And then what we did was we created a one-to-one NAT. So Nova actually gave out the IP of the VLAN that we created, and then we had a table that showed the map. So like, let's say you request a VM, you get this private IP, but we tell you that look at this chart like in our wiki, and then like, like this gets a public, and this is the public that corresponds with that private. And then also something to talk about is scaling. So what we found is once you spin up a private cloud based on your business use, it becomes pretty popular, right? So it's very easy to scale. If you notice the two clusters at the top, the one that says computed management, since again, those are just clusters like clusters within vSphere, you scale that out like just as you would like your normal compute cluster. You can add hosts, or if you want to, you can add more clusters. So for example, let's say you buy, let's say you want to buy white boxes, and you can't put the white boxes in your pre-existing cluster because like the CPU architecture is different. You can just add another cluster. Some things to consider, like if you guys do deploy VIO, or like if you just deploy a cloud platform, things to think about. Creating an operational dashboard was pretty important for us because there are management tools that ship with these products, but you sort of want to get visibility to the logs, right? And there's logs all over the place. There's a log for, like all the components of OpenStack, and times 2, times 3, based on how many of those nodes you have, right? Because you want to have fault tolerance and redundancy built in. So, sort of using a tool to grep all those logs and come up with a dashboard was helpful for us. So we got to show health, the uptime, the errors, and then we also use that dashboard for monitoring. So like, how long does it take to spin up an instance? Why is it taking so long to spin up an instance? Did something fail? Like, is a component not working properly? And then the cool thing we used it for was forecasting usage. So you can come up with like a basic formula to look at your trend, and then based on your workflow for buying hardware, you can say, all right, let's not wait till we get to 100% capacity. Let's probably around 60%. Let's just place an order for new hardware, and because it takes 2 weeks to get here, and then it takes another couple days to rack and stack and network and all that stuff. So we used it for forecasting, and then something to consider too: lease times. The public cloud or the private cloud gets very popular, but because there's no like chargeback model like the public cloud, where it's like if you leave your VM on, it's going to hit your credit card, right? That doesn't happen in the private cloud. So something to consider about doing is lease time. And lease time does not come by default with OpenStack. So you can use whatever cloud scripting tool you want to use. We just happen to use Puppet, and we have a manifest that looks for the age of the VM. And then at 1 week, we say, we send an email to the owner and say, hey, within 1 week, your VM will be terminated. Just like a little FYI. And then on the 2 weeks, we just kill that VM instance. So to summarize real quick before I pass it back to Arvind, it all started with looking at the public cloud, trying to come up with a solution to hedge that public cloud, and then the best solution for us just happens to be VIO because of the rich networking, the DRS functionalities, and then the support, and then of course cloud formation with OpenStack. So thanks.
All right, thanks, Lawrence. I love his phrase, 16 digits to freedom. You put your credit card and you're all set, but then the bill comes, right? So that was the motivation for TradeStation. I mean, if I had to summarize, you have a deep cost analysis, and you want to repatriate some of the workloads, mostly the workloads that are less elastic or bursty in nature, and you want to do it in your private cloud. That's a perfectly valid use case that we are seeing across multiple customers, right? Over time, pay-as-you-go model just becomes quite expensive. So let's talk about VMware integrated OpenStack and why our distribution is where does the differentiation lie. And I'm going to go back a little bit to the strategy. As I mentioned, we are contributing We are differentiating. All the rich features of our products are available for your OpenStack cloud as well. Now, the biggest point is how do we enable you to successfully deliver and operate OpenStack in your cloud? And we want to simplify all of that, right? We want to leverage your existing expertise in running the data center. And since OpenStack is just a piece on top of it, I think we can do it in a very smart fashion, right? Leveraging your expertise, essentially. So building the cloud is the first step. In no way it's easy, just because it's at the bottom corner on the complexity. It's not easy, but it is just the starting point. Once you build the cloud, or you get some consultants to build that cloud, you still have to monitor it, right? As I showed, there are like 5 or 6 Nova, Neutron, all these Python services going around. You've got to be able to monitor which one is up, which one is about to die because of the storage running out or network not being reachable for it. So monitoring is crucial. Without that, you can't go to production with peace of mind. Next thing is, hey, my VM is not getting an IP, I attached a disk, it's not responding, those kind of problems, that will definitely be there. We have seen that in public cloud as well. So troubleshooting is crucial. One aspect of OpenStack, it generates a lot of logs, very generous with logs, right? Each service has about 5 or 6 logs, 5 of those services, about 30 plus logs, some peripheral components, more logs. All of a sudden, you are in a log utopia, right, or nightmare. Scale up the cloud, scale down the cloud. Those are usually tasks that you will do, as Lawrence was saying. Once you get a hang of how much demand there is for your services, you will either add more capacity, remove more. Removal is the one where you need a lot of work. How do you migrate those workloads and things like that? But it's still challenging without bringing downtime or bringing the whole cloud down, for that matter. Upgrades and patches, right? When we go talk to customers who are doing OpenStack in production, hey, what version are you running? Well, we are on Grizzly. Whoa, that was 2 years ago, 1.5 years ago. Why? Well, it's doing what we are supposed to do. Why should we upgrade? Well, what is the real reason? Well, there is no easy way to upgrade at this point, and it brings a lot of uncertainty when you move from Grizzly to Havana to Icehouse. By the way, these are all OpenStack releases, fancily named. So where do we come in, right? First of all, we want to bring our operational tools into the mix. We have laid the foundation, we have built, made sure that OpenStack can run on our infrastructure products. Now we want to bring in the operational tools, things like VCOps, Login Site, even vCenter. We want to bring those and give you the tools so that some of these complex tasks become easier and take less time so that you can go to production. Now, the most important part of this, anyone can provide you the tools, but the familiarity of those tools is what accelerates it. That's what reduces the complexity. So we want to leverage your expertise to reduce the complexity, right? As I call it, no OpenStack TSD required. I'm going to come back to that one. But that's the core goal. That's the goal of VMware Integrated OpenStack. Our operational tools, your existing expertise, we bring down the time that it takes for you to go to production confidently. We want to accelerate that, right? If you want to use OpenStack, let's get to production. Let's start using it. Let's build more features so that your developers are more happy. There's a lot more to do. We don't have to get stuck in building the cloud and operating it, right? So what is VMware Integrated OpenStack? At the bottom, it's all of our products, the vSphere product for the compute and the storage. There is the NSX product for networking. There is vCenter, vCops, Login Site for management. I already showed that these things are already integrated with our foundation products, the infrastructure part. The new piece that we are adding is an installer and a configuration management tool, which will allow you to deploy OpenStack, a production-grade OpenStack, right from the vSphere web client. And we're going to do that towards the end of the session. I will be able to build an OpenStack cloud. That's so funny, because I would not have been able to do it without this product before. All of this bundled together, delivered as an OVA. It's a distribution. It's a distribution optimized to run on our products, right? It's delivered as a virtual appliance. It leverages all of our installation and management tools that we have. So that's what it is at a very beautiful orange and dark blue color. Let's zoom in a little bit. Let's get more real, right? So those are the foundation pieces we already saw. These things are new. So vSphere web client will allow you to install OpenStack. It will allow you to configure OpenStack. You will use familiar abstractions like clusters, data stores, distributed switches. You will use those to configure and deploy your OpenStack. You will use things like Log Insight to analyze the logs, or for that matter, any syslog server. But don't do an OpenStack without a syslog server. That's the gist of that. Later on, towards the later part of this year or early next year, we'll announce a VCOps OpenStack management pack. What this management allows, it's aware of all these OpenStack services that are running, and it keeps monitoring them. So if, let's say, Nova fails and none of the VMs are getting created, you will get an alert. You can monitor it all from the central dashboard, right? The Swift is an interesting one. Some of the customers that we talk to, they want to use Swift for object store. They want to put multimedia files over there. So this is an example where VMware does not have a product, and we want to leverage our ecosystem of partners such as EMC, or for that matter, any other. We are having conversations with a lot of other storage vendors. But EMC Viper is a great enterprise-grade solution for object store. It delivers the complete object store services. It's geo-replicated. It's highly performant. It's something that you would need, and you don't want to build again an object store from white boxes. I've seen that happen again and again, and there's a lot more to it than just putting some disk behind Swift, right? So if you want to use Swift for your multimedia files and create an S3 kind of a service, then you want to have an enterprise-grade object store solution, and EMC Viper is one of the leading solutions in this space. I wanted to use this as an example for our ecosystem and why ecosystem is important. If anyone says that the single company can help you build the entire data center, I would take that with a pinch of salt, right? There is a lot of technology involved in running and building a large-scale data center, and ecosystem is crucial. So VIO, right? Coming back to VIO, it empowers you, the VMware administrators, to be able to successfully deliver, not just deliver and build it and leave, but also to operate the cloud, because the cloud has a life, right? So what are the key value propositions that we are claiming for our distribution versus others? It first of all runs on all the good, solid, proven technologies, vSphere, NSX, vSAN. Second, more importantly, no OpenStack PhD required. You don't need to go to University of Phoenix to find an OpenStack course, right? They don't have one, but there is no need for that. We want to bring down that expertise or the need for that OpenStack specific knowledge, right? And the way we are doing that is by using your existing vSphere expertise. As I mentioned, you configure things using data stores, clusters, things like that. You're starting from vSphere web client. You don't have to learn any set of new tools and things like that. Simplified OpenStack operations. As promised earlier, we are going to deliver you tools that will make the operations really simpler. And the one interesting aspect of VCOps is that it can monitor the OpenStack services. It can monitor your virtual plane, the vSphere, the NSX, and it can monitor some of it had, if you're using one of the physical servers where we have the management pack, it can monitor that as well. So you have a unified view from all the way from OpenStack to virtual layer, all the way to the hardware layer. This is pretty beneficial. If your glance is, or the image store is failing, because the storage is having issue underneath, you can go drill down step by step. Last but not the least, definitely not the least, this has been a lot of challenge in a lot of customers. Single vendor support. Well, you're running around, hypervisor is having a problem, you're chasing one vendor, OpenStack is having a problem, you're talking to another vendor, your operations tool is not responding, you're talking to another vendor. That wastes a lot of time. It creates downtime in your data center. You want a simplified support model, right? That's crucial. We should take that factor into account. Everybody needs help in running the data center, so there should be at least an easy way to get support for across the stack. Our distribution is no different than any other distribution. It's the same. We take the OpenStack upstream code. When the community announces the next release, we will take that, harden it, package it, and deliver it in our distribution. So it's the same code. There might be few patches that didn't make it upstream that we will add because it's crucial to the customer, because it's a bug, right? We will add that into our patch, deliver it to you, and make sure that it gets merged upstream when the review cycles are completed. But the gist of it is it follows the OpenStack upstream release. There is no secret sauce that we are adding. It's the same standard OpenStack APIs and services that's available upstream. So enough of the talk. Let's try to build an OpenStack cloud. That should be exciting, right? And if I can build it wearing a blazer, I am definitely sure you guys can definitely build it. So let's start over here. You start with deploying a simple OVF, just like you guys are familiar with doing OVF. The first thing it asks for is vCenter credentials. Why is that needed? Because Nova APIs or Cinder APIs, they talk to vSphere, right? So this is for APIs to talk with each other. That's for the authentication piece. Pick a cluster. Where do you want to deploy these OpenStack components? Just pick one cluster that has minimum amount of resources needed for this. It goes ahead and deploys that. Requires 2 networks. One for the external horizon and API access for your developers to consume the infrastructure. One for the internal management traffic. Really simple, straightforward. If this guy typed faster, I could move faster. I don't have a fast forward. All right. So once the networks are specified, it's all highly available architecture out of the box. It has a load balancer in the front. The load balancer has 2 whips, one going outbound, one inbound, right? The load balancer is simple HA proxy. It enables us to create a scale-out, highly available architecture for the OpenStack components. As you can see, all of these components are going to get automatically created. And these are minimum required components to run in production-grade OpenStack. We have not added any extra things. This, you can look at various architectures. They pretty much have all of those components. Once you have done that configuration, assign some clusters that your tenants are going to use. This is where the tenant VMs, your developer VMs, they will go. So you can select multiple clusters. Select the data store for those VM files to reside, right? As you can see, you can use vSAN for those data stores, for those VMs. Networking, you have a couple of options. If you have NSX, you can use NSX. If you don't, then you can get started with VDS, distributed switch. It will give you basic L2 networking. But as Lawrence mentioned, any kind of significant real-life application needs more than a simple L2 network. So NSX will probably be needed the more mature you get in the use case of the cloud, right? But you can get started with VDS. Again, we need this guy to type faster. We are all hungry over here, and I want to get my OpenStack cloud running, my developers happy. All right, next. Once that's done, all you need is an admin password for your Horizon. This is the password that you will use to log in to create users, give them quotas, and then we are all set. And this will go ahead, and what it will do is it is going to, before I forget, the syslog server. That's very important. As I mentioned, there are like dozens of logs that are created. You need a syslog server. Please don't do OpenStack any which way without a syslog server. We were doing it early on. We learned from our mistake. As you can see, if you did all of these configurations by hand or from scratch, it's going to take quite a significant amount of time. Even if you're doing it twice or thrice and have done it before, it just takes time, right? And by time, I mean weeks and months. It's not talking a few minutes or hours. It's going to go ahead and clone all those VMs. So what is it creating? It's creating things like message queue for Nova to talk with Cinder and things like that. It's creating memcache so that Keystone is performant, right? Keystone gets hit by a lot of session authentication requests. It's creating memcache so that it can actually scale to that level. It can handle your hundreds or thousands of VM authentication requests, right? It's creating databases, highly replicated databases so that you can store your OpenStack metadata. You can move those to other OpenStack installation if you're doing migration. It's creating things like, what else is in there? I forgot. Load balancer, of course. The load balancer is there, and the OpenStack services, right? So all of this roughly comes down to, I think, 15 VMs is what it creates. And you have your OpenStack cloud ready. It's a production-grade OpenStack cloud. It has highly available architecture. It's an easy scale-out model, all from the comfort of your vSphere web client, right? So that's the promise that I made earlier. What's the differentiation? The differentiation is really in your existing expertise, leveraging your existing investments, bringing VMware integrated OpenStack, and bringing OpenStack to your VMware private cloud. With that, I am open to take any questions. I would highly encourage you to sign up for the beta. The beta is available at the product page. I would highly recommend going to the 2 o'clock session. It's going to cover installation, usage of OpenStack, creating a 3-tier application, to operating OpenStack in a more comprehensive, from end-to-end kind of a demo, right? So that one is very technical. I would highly recommend going to SDDC2370.2. With that, if you guys have any questions, I would love to answer them. And thanks for joining. Thank you.
Thanks.
Thank you. Could you please come up to the mic so that the recording people can get the questions?
So which version of OpenStack that you guys use?
Excellent,
Right now?
soft starter question. It's Icehouse.
Icehouse. And yeah, so what is the size of the cluster? Because you told it's a production grade OpenStack that gets deployed, but
Yeah.
how do you know like what is the size, what kind of size it is like?
Yeah, so there is a sizing guideline. We have documented all that. It's available. Once you join the beta, you get to see all those documentation.
Okay.
It's nothing fancy. It's running, I'm not supposed to say which version of Linux or what vendor, but it's running a Linux operating system. Most of these VMs are pretty thin and small, so it's not that terrible.
But typically how many hosts and
We require for the management cluster 3 hosts, just for the HA. And the storage footprint is also not that big. So it's pretty minimal to get the control plane of OpenStack. Then you can add as many tenant clusters and things like that, right?
and I'm assuming it's a public beta, right? So
It's a private beta, but we'll go through the nominations. It's mainly to handle the support load. We have limited support people right now, so we'll ramp it up.
okay.
Any other questions?
Yeah, which versions of NSX? Is it multi-hypervisor and
Yeah,
vSphere, or is just multi-hypervisor?
Currently, it's NSX MH. We are working on NSX vSphere.
So
It's
we
gonna come
should
sometime.
expect that in the future.
Yeah.
Okay.
Sometime soon, yeah. Any other questions? You guys like it, don't like it, helps, does not help? Any comments? We got 5 minutes before lunch. It's awesome? You're from VMware. Any neutral, outside vendor comments? Good? No? All right. Hungry? Let's go food.
Thanks, guys.
Thanks for joining, guys. Thank you.